Hello, grade 10s. I hope that you have had a restful holiday and that you are ready for a productive term this term. I hope that you've gone over some of your notes and everything and you're ready for the section. What we're going to basically do is for this first lesson, I'm just going to go over some of the topics that we previously discussed in Trig last term. Obviously, these lessons, they're going to be a lot shorter than what the lessons are that I would give in class, but if you need to pause or go back and just hear again what I had to say, then please do so. Remember that you must interact with the lessons and you must take notes and you must do everything as if it was just a normal lesson. But obviously, because I can't answer any questions or anything like that, then you're more than welcome to pop me an email or comment under the video in Google Classroom, and then we can and then I can answer whatever questions you might have. Okay, so what I'm just going to do is I'm going to start off by, so you can open up to a clean page in your book. You can turn it sideways so that it's horizontal. What I'm going to do is I'm just going to give a summary of basically everything that we covered last term for trigonometry, and then you can just make a little note on this particular page, and then you can use this page in order to study from or use whenever you need. Okay, so I'm just going to go to the center of my page and I'm going to write trigonometry notes. Okay, so we're going to kind of do like a mind map just to get the basics down so that we don't have to page and page through all of our notes just to find the basics of what we're trying to do. So the first thing, if you can remember, that we discussed, I'm going to put in this left hand corner, is the ratios. Now I'm sure you've established that when we were doing ratios last term that there are two types of ratios. The first type is where we look at the ratios in triangles, and the second type is where we looked at ratios in the Cartesian plane. Okay, so when we looked at triangles, we specifically looked at right angle triangles. And we said, okay, well, if theta, the angle, is there, then we would define the three sides of the triangle. The first one being the hypotenuse for h. Obviously, the hypotenuse will be the same regardless of where theta is, because remember the hypotenuse is the side that is opposite to the 90-degree angle. Okay, then the opposite side is going to be the side that is opposite to the angle, and the adjacent is the side that is next to the angle. Okay, when we use these ratios, we can use our three functions. We say sine of theta is going to be equal to opposite over hypotenuse, that cos of theta is equal to adjacent over hypotenuse, and that tan of theta is equal to opposite over adjacent. Okay, or as we know it to be SOHCAHTOA. Okay, so it's important to remember that this is only used, these three ratios are only used for when we are dealing with triangles alone. So just triangles. Okay, but as soon as we start going into the Cartesian plane, we use a different set of ratios. So on our Cartesian plane, right, we have the two axes, the y and the x. And we said that, well, if I draw a line on this, in this Cartesian plane, to make an angle theta, then I would make a right angle triangle. and I would call the hypotenuse r, and then I would have x being on the x-axis and y being parallel to the y-axis. That's why it's called y. Okay, this x, because it's on the x-axis, it's easy enough to just call x. Okay, important here is to remember that before we can do anything, we must remember that we can use Pythag to obviously solve for whatever missing angles we need. We can use Pythag in the previous triangle as well, but I mean, I think that's pretty straightforward. So it's just important to remember that r squared will be equal to x squared plus y squared. Okay, and we know this because of Pythag. Okay, so if we continue, we'll see that, well, our ratios now, sine of theta, cos of theta, and tan of theta. Notice that when we look at this triangle, sine of theta is opposite over hypotenuse, but that hasn't changed. When we go to theta, we see that the side that is opposite to theta is still going to be y. So it's not like we are reinventing the wheel or doing something completely brand new. We're still doing the same thing. It's just now we're going to use coordinates on the Cartesian plane instead. So we're going to say, well, opposites of hypotenuse in this case would be y over r. Then adjacent of hypotenuse would be x over r. And the last one where we would have opposite of adjacent would be y over x. Okay, well, another way to remember it is, like we said, the sine your rear, cos x rays tans your exterior. Okay, it's up to you on how you are going to remember it, but like I said, these are the most important ratios that you need to learn throughout the entire trig section. Okay, moving on. The second point that we looked at is what we call the cast rule. You'll see later on we also refer to it as the reduction formula. Okay, but we don't really look too much at reduction in grade 10. So we start off by drawing our Cartesian plane, and we understand that on this right hand side we start with the angle 0 degrees, and when we are measuring angles we then measure going counterclockwise. So because it's divided into 4, by the time we get to this one we get to 90. Okay, then we would have 180 degrees on the left hand side, and we would have 270 degrees at the bottom, and then when we get to the original point we would be at 360 degrees to make a full circle. Okay, in order for us to know what quadrants we are talking about, we number them. So we would number this one as the first quadrant, this one as the second, the third, and the fourth quadrant. Okay, and then by doing so, we can then use our cast rule, C, A, S, T, and remember that the A is for all, where all functions are positive in the first quadrant. The S is for sine, which means that sine is positive only in the second quadrant, and the other two will be negative. So sine is positive in 2 quadrants, the all and its own quadrant. Then the T is for tan of the tan function, which means that tan is positive in the third quadrant and also in the all quadrant. And the last one is for cos, which means that cos is going to be positive in the fourth quadrant and also in the all quadrant, the first one. Okay, so this is vital to remember because we're going to use it later on in grade 11, but you also need to use it for our ratio calculations, which we did around the last week of last term. Okay, so moving on, we then looked at solving equations. Solving for angles specifically. So the most important thing to remember here is that you always want the function on its own. Okay, so that means that we want the function, or the equation rather, to look something like that. Okay, we don't want any p's, or we don't want any 2 sine thetas or 2 plus sine of thetas. We don't want that. So if we had something like 3 plus 4 sine of theta is equal to 2, the first thing we would say is, well, 4 sine of theta would equal to 2 minus 3 to get rid of it. And then we would say, well, then sine of theta is equal to negative 1 over 4. Okay, so once we are at this stage, then we are happy to move on from our, in order to solve for our angle. So important to remember is that you can never divide by sine of nothing. Okay, sine of nothing doesn't exist. There always has, it's part of a particular function. So if we want theta on its own, then we have to use a special rule on our calculator, which is the arc sign or shift sign, and then we'll put the number on this side in brackets. So on your calculator, you find where sine is, and you'll notice that if you press shift sign, it'll give you the sign to the negative 1. Okay, that is only when you are solving for theta. So be very careful. It's not sine of negative 1 over 4, it's arc sine of negative 1 over 4. Okay, we're trying to solve for this particular angle. So if you move this function to the other side, you have to arc sine it. No dividing or multiplying, your arc or shift signing it. So on your calculator, you would just say arc sine of negative 1 over 4, and you would get theta to be equal to negative 14.48 degrees. Okay, we'll leave it like that for now. I know that a negative angle doesn't really seem intuitive, but for right now, we'll leave it like that, because the goal here is to just solve for theta. Okay, then the last thing we did, which I'm sure you all remember, is the special angles. So the most important thing about special angles, besides knowing exactly what they are, is obviously that you need to learn them off by heart. Okay, because you are not allowed to use a calculator. Okay, so that's very important to note here, is that if you're going to use a calculator, you're going to lose the marks allocated to finding special angles. So you have to make sure that you learn all the triangles in the Cartesian planes in order to do this. So first thing is to note that you have 5 special angles. They're going to be 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay, the more you do trig, the more you'll realize why these 5 angles are so special and why we use them so often. Okay, especially when we get to the functions and the graphs and things, then you'll understand exactly why it's these particular angles that we use. Okay, so just like our beginning, where we spoke about the ratios, that there's 2 types of ratios, in triangles and in the Cartesian plane, there's also 2 ways that we solve for special angles. It's in the triangles which is specifically for 30 degrees, 45 degrees, and 60 degrees. The other way is to use the Cartesian plane, which is for 0 degrees and 90 degrees. So, if we look at the triangles, there are two triangles that you have to learn off by heart. Okay, the first triangle is for the 45 degrees. So all we do is, for both triangles are going to be right angle triangles. Okay, that's easy enough for us to understand. But when we look at the first right angle triangle, the first one is going to be an equilateral, well, no, not equilateral, sorry, isosceles triangle, which means that we'll have two sides that are going to be equal to one another. And it's obviously not the hypotenuse, because remember the hypotenuse is the longest side. So it can't be equal to another side, otherwise it wouldn't be the longest side. So these two sides that we make equal, we have a 1 unit for both of them. And by doing so, we can figure out that the hypotenuse is the root of 2 just using Pythag. And if you can remember from geometry, if this side is equal to this side, this angle is equal to this angle, and 90 degrees, if I take 180 minus 90, I get 90. So if I'm missing two angles that are equal, I would just divide by 2 and I would have 45. So I would have 45 degrees, 45 degrees. Okay, remember you don't have to necessarily know exactly where it comes from, but I think it just helps when you are trying to learn it to remember actually why we do it and how we get to these answers. So the second right angle triangle, what matches is that we have the 1 both being at the bottom. So just a way for you to not forget that we have 1, and now the hypotenuse, instead of being the root of 2, is going to just be 2. So again, we could use our Pythag to find that this side is going to be the root of 3. And then we would have our angles. Now, the angles, the one that is going to be on the base of this triangle between the two bigger sides is going to be 60 degrees. Well, the root of 3 wouldn't be bigger than 1. But between 2 and 1, we would have the bigger angle. And between 2 and root 3, we would obviously just have the missing angle. Okay, then that's it for our triangles. So if we're talking about the sine of 30, because we know sine is opposite over hypotenuse, we could go to 30 and say, well, sine of 30 is opposite 1 over hypotenuse 2. So sine of 30 is just a half. If I said something like cos of 45, I would say, well, cos of 45 is adjacent, which is 1, over hypotenuse, which is the root of 2. So I would have 1 over the root of 2. And so that is how we continue using this method, is that we find the angle in the triangle that we need, and we just need to remember the ratios that we use. Okay, then the Cartesian plane is for 0, 90 degrees. So this one is slightly different because the triangles don't work for 0 degrees and 90 degrees. And I think that should kind of make sense to you, because how could you have 0 degrees in a triangle? That wouldn't make sense. So that's why we have to use the Cartesian plane for both of these. So we notice that 90 degrees again is still at the top and 0 degrees is here on the right. And what we do is we draw a circle which has its center at the origin. So there, in the center. So the radius, which I can see is equal to all 4 of these lines, Okay, remember the radius is just a line from the center to the circumference, is going to be 1. Okay, so it's very important not to confuse this. Okay, we're not talking about this type of r, although hypothetically speaking, if we did a circle with which these were equal, then it would be equal to one another. But that's not what we're looking at now. So don't get confused and think, okay, well, this must be x. Although it is x, it also represents the radius of the circle, which is 1. So because the radius is equal, this will be 1 unit. So y will go from 0, 0, 0 to 0, 1. Okay, remember x is still going to be 0, but the y value has now increased to 1. And on the x-axis, it is the opposite way around, because if I notice x has a value now of 1, but y is going to still be 0 because you measure on the y-axis. So now we can use this in order to figure out the rest of our functions. So if we wanted to know what sine of 0 degrees is, we would say, well, we know that sine is y over r. So because we know that r is already 1, that's pretty straightforward. But then y we find at 0, which in this case is 0. So 0 over 1 is just 0. Okay, let's try a cos of 90 degrees, where I know that cos of 90 is just going to be x over r. So I go to 90 and I say, well, the x is 0 and the r is still going to be 1, so it will be 0 over 1, which is just 0 again. Okay, so this is essentially how we use the special angles. So like I promised, I will teach you another trick on how to do it, but you must learn this triangle and this Cartesian plane to find special angles. Okay, it is a vital skill to have in trigonometry, so it's very important that you do learn how to do this. Okay, so that essentially concludes what I would like to explain during this lesson. So what I need you to do now for me is you go to your exam focus, which I believe is on page 159. So for your homework activity, which I'll do corrections for in the next lesson, you're going to complete questions from the exam focus on page 159. Okay, what I would like, so obviously the whole exam focus is something that would be quite helpful for you to do, but I don't necessarily want you to have to do every single question for me right now for homework. But what I would like you to do is question E, the whole thing. Okay, question E is special angles. So it's important to remember, and it even says in the question to do it without a calculator. Okay, then I would like you to do G, which is going to use triangles, and also H. Okay, so pretty straightforward, not too much to do. So it's important that you go over this before our next lesson to make sure that you're understanding what is going on, because obviously in the next lesson we're going to move on. Okay, grade 10s, I hope that this was helpful. I know that it is a bit strange doing lessons like this, but I'm sure that within time you will get used to it. And like I said earlier, if there are any questions or anything that you would like to ask me, then just pop a comment on the Google Classroom, or you can email me directly if you would like to. Okay, just maybe give me a bit of time to respond to you. But other than that, you're always still more than welcome to send me any questions that you may have. Okay, so good luck. I hope that this term is a fruitful one for you, and we'll see each other on the next one.